All right, it cut me off. I don't know why. Okay, so we've got AA, blah, blah, blah. We're matching them up. Cool. All right, once you've matched them up, we need to identify the chances that this child will be albino. So I just start with identifying which genotype is going to make the child albino. So remembering that if there's a dominant allele present, that one will always be expressed. Okay, so these three are not going to be albino. The only albino one here is this double recessive, which is called homozygous recessive, because they are the same. These will all express normal pigmentation because the dominant allele is present. Okay, so when we ask what are the chances that the child will be albino, you write in a full sentence, the offspring or the child has a 25% chance of being albino, okay, because it's a quarter, and a quarter is 25%. I don't know how I can explain that one anymore. All right, so you've answered the question, but you always have to show you're working out in a question like this, okay? Now, another thing I just want to mention is this is our cross. So what is the cross that we are doing? Okay, we call this the the parental generation. Okay, so they will normally just have a P, okay, and then they'll have the cross. I'll see if I can show you. A example, hopefully. Oh yeah, okay. So you can see here P1. All right, so that means the parental generation. Okay, who are the parents of this cross? Okay, so who's being crossed? That's them. All right, their children, or their first generation of children, are called the F1 generation. Okay, which is first generation, I guess. All right, so that's them, these offspring. Now, if we take two of these guys and mate them, and they have children, that's then the F2 generation, all right, which happens in plants and animals. Okay, I'm not saying it happens in humans because that would be inbred, but it does happen in plants and animals. So you will get scenarios that ask to cross to F1 generation, and that's just what you're crossing is these guys here. All right, let's go to the next one. Hornless H, whoops, what am I doing? All right, so remember you're working out. I'm going to do just a quick notes because I just like to have it in me, or you would just highlight, I suppose. So hornless is a dominant trait, obviously, because it's a capital letter. So it's capital H is dominant over horned. Okay, so we've got hornless being dominant versus the recessive, which is horned. Okay, so that's what they equal. All right, now we're going to take a homozygous hornless bull. So take your time, work through it slowly. Homozygous means the same, so they must have two of the same alleles. And it's hornless, okay, so it must have two of these dominant alleles. It must look like that. It's going to be mated with a homozygous horned cow, okay? So homozygous horned cow, the same, and it's horned, so it must have two recessive. Okay, now what will the genotype and the phenotype of the first generation be? Oh look, I had an example here all along, silly me. Anyway, so when it asks you for the P1, it's asking you for the parental genotype and phenotype. Okay, so this is what I would write. I'm literally crossing these two. They're the parental genotype. And then I just put the phenotype in brackets. Okay, so that's what P1 would be. That's our cross that we're doing, monohybrid cross. And now we are going to do a Punnett square to work it out. All right, which let's put it on the other side. So we want to know the first generation. So let's plug in our parents' genotypes. All right, then we match them up. And you'll get to the point where you can do these in your head, but you should always show you working. All right, so our F1 generation, we want to know the genotype and the phenotype. All of them are the same. Okay, so they are 100% HH, 100% chance, I should say, of being heterozygous. Didn't spell that right. Nope. Okay, and then we need the phenotype. So they are going to be 100% hornless. Okay, so that's how you work through it. If you've got any questions, just email me. But you can watch this video as many times as you like. See ya.